Chapter 3, Section 8 is about finding and estimating square roots. By the end of this lesson, you should be able to find square roots, and then you should be able to estimate and use square roots. So a couple vocab words. First of all, a square root is a mathematical operation that undoes squaring a number or multiplying a number by itself. So if you have that 2 squared equals 4, the square root allows you to go backwards, and you can take the square root of 4 and get 2. And then there's 2 different answers that you can get. You can get the principal square root, which is the positive answer, or the negative square root, which is the negative answer, and we'll talk about that in a second. And then the radicand is whatever's underneath the square root. So this symbol is called the radical, and then anything underneath is your radicand. And then a perfect square is the square of all of the integers. So it's whatever 1 squared equals, whatever 2 squared equals, whatever 3 squared equals, blah, 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 blah. So in this diagram, it shows the relationship between squares and square roots. Every square root technically has 2 square roots. And it's because if you take positive 4 and square it, you're going to end up with 16. But if you take negative 4 and square it, remember this is negative 4 times negative 4 because it's in parentheses, you will also get 16. So technically, when you take the square root of 16, there are 2 possibilities. Because what this is asking, when you see this, is what number squared will give me 16. So there's 2 possibilities. 4 squared does it, and negative 4 squared does it. So number A is a square root of B if A squared equals B. So the radical symbol indicates square root. The expression square root of 16 means the positive or principal square root of 16. So that's usually what you guys have seen in the past. The expression negative square root of 16 means the negative square root of 16. So here your answer would be positive 4, and here your answer would be negative 4. The expression under the radical sign is a radicand, and you can use the symbol plus or minus to indicate both square roots. So you can see it here on part B. I want to find both the positive and the negative square root of 36. So the first one, square root of 49, you are trying to figure out what number times itself gives you 49. And hopefully you know that that's 7, because 7 times 7 gives you 49. Now the next one, because it has the plus or minus on here, when we find what number squared gives us 36, that answer's 6. But we want both the positive and the negative answers, so we have to say plus or minus 6. And then this is the negative square root of 121. So the number times itself that'll give us 121 is 11. And because of the negative, we want negative 11 as our answer. And then the next one is a little tricky, but we will learn a rule eventually in Chapter 11 that says that you can take square roots of fractions and split them up. And both of these are perfect squares. They're numbers that you should have memorized. The square root of 1 is 1, and the square root of 25 is 5. So the square root of 1/25 is 1/5. Some square roots are rational numbers and some are irrational numbers. So a rational number is something, remember, that we can write as a fraction. We could write this as 10 over 1. Even this, we could write this as 6/10. And then obviously this is already a fraction. Irrational numbers are the ones that aren't nice and pretty. They don't repeat, and they don't terminate. Remember when we talked about these, those are the 2 things that mean it can be written as a fraction. So all we have to do for this is tell whether it's rational or irrational. So basically you're figuring out if it's something that I can write as a fraction or a decimal. So the square root of 8, if you type that into your calculator, you are going to get 2 point blah, 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 blah. It doesn't terminate or repeat, so this is irrational. Now the next one, 225, the square root of this, if you type it in your calculator, you will get a nice pretty 15. So that means that this is rational. That number can be written as a fraction. Now the next one, the square root of 75, if you type this in your calculator, you get 8 point blah, 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 blah. So again, this one's irrational. And this one, the square root of 1/4, remember we can write as the square root of 1 divided by the square root of 4. So this just gives us 1/2, which is a fraction, so rational. So now using and estimating square roots. So the squares of integers are called perfect squares. So numbers like 1, 4, 9, 16, 25, 36, like the next one would be 49, and we could keep going all night. These are perfect squares. And if you think back to what you know about that Looking for Pythagoras book that we did in 8th grade, they were the ones that when you connected dots, you made right side up squares, not the tilted squares. These ones here, because they're tilted, you get a fraction or a decimal for your answer on how long the side was. Because remember, all a square root is the length of a square. So taking the square root of a perfect square will give you the dimension of one side of the square. This right here was the basis of that Looking for Pythagoras book. The important thing about perfect squares is that they are squares of whole numbers. So that's why we have squares and square roots, because it's literally describing the area of a square. So if we want to estimate square roots, we can think about the perfect squares that we know. So we listed some of them here, 49, and we could keep going. The next one after 49 would be 8 squared, which is 64, then 9 squared, 10 squared, 11 squared, 12 squared, and we could keep going forever and ever and ever. But if I want to figure out what two consecutive integers this square is in between, I got to look between the perfect squares. So 105 is going to be right in here. And remember, 100 is 10 squared, and 121 is 11 squared. So this answer, when I type it in the calculator, is going to be somewhere in between 10 and 11. And hopefully you can see it's going to be a little closer to 10, because 105 is closer to 100 than it is to 121. So this is going to be in between negative 10 and negative 11, because we have this negative out here. Between what two consecutive integers is 14.52 if we take the square root of that? So let's go back to these ones right here. 14.52 would be right here. So if we want to take the square root of this number, our answer is going to be somewhere in between the numbers 3 and 4. And you can type this in your calculator to check, but you should be able to kind of figure out where it's going to be without your calculator. So we need to find the square root of 17.81 and round to the nearest hundredth. Now in order to do that, we definitely need a calculator. Using the strategies that we just did, I know that my answer is going to be somewhere in between 4 and 5. But if I type this in my calculator and hit the square root button, I get this giant decimal, 4.220189569, blah, 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 blah. So the nearest hundredth, remember 100 has 2 zeros, so it's 2 numbers after the decimal. So this is where I got to round to. Since this number is under 5, I'm just going to leave it as 4.22. Now the next one, find the square root of 14.52 to the nearest hundredth. So again, I can just type this in my calculator. I know it's going to be somewhere in between 3 and 4. And I get 3.81 to the nearest hundredth. So, can you find square roots, and can you estimate and use square roots? You got 3 questions to answer. Write down any questions you have, and we can go over them tomorrow in class. Have a good night.